Okay, I'm not going to be able to do all of these today, but I thought I'd start with a question 1 out of homework 4 about nodal analysis. And this is my solution to my version of the problem. Okay, so the first thing to note is we want to identify the nodes, and we've already got them labelled in the question, so nodes A, B and C. So we've got 3 voltages we need, VA, VB and VC. So that means there's 3 unknowns and 3 equations we need. So the first question is about the types of equations. Normally, nodal analysis will end up with, we'll use Kirchhoff's current law, right? But in this case, because we've got the voltage source, we're actually going to use KVL to do our freebie, right? So VA equals VS is our KVL equation. And the others will be our KCL equation for B and our KCL equation for C. Okay, so IR1, IR2, IR3, and we've got our voltages that way, and yeah, and V out is correct. So then if we look at our the equations, as I said, the KVL, now we've got VS, so we can just say that that's equal to 10 volts, which is what we've got here. And one thing that a lot of people have been doing is they've been leaving off the K, right? So 6K ohms is equal to 6,000 ohms. So make sure you add the thousands in there. Otherwise the equation probably won't work. And then our KCL, well, let's do the individual items. So IR1 is going to be VA minus VB on R1. IR2 is going to be 0 minus VB on R2, and IR3 is going to be VC minus VB on R3. Okay, so then our KCL at B is going to be, they're all flowing in, so it's just IR1 plus IR2 plus IR3 equals 0, and we can replace that, and it should be an R1. I didn't put the 1 there, so that's VA minus VB on, and what is R1? R1 is 6,000 plus, oops, no, it's going to be minus, isn't it? So minus, and it's VB on, and R2 is 7,000, and then it's plus VC minus VB on R3, and R3 is 10,000, right? And that equals 0, right? And that's what I've got here, and that's correct. And then the KCL at C is just going to be, well, IS is the current flowing into the node, and IR3 is the current flowing out of the node. So IR3 is VC minus VB on 10,000, and that equals whatever we've got there. So this is another one, it's 550 by 10 to the minus 6 because it's microamps, not milliamps. So it's 10 to the minus 6. And I've rewritten it here as, I've rewritten this as 0.00055 amps. Okay, so that's how we get that answer there. Then it's just a matter of rewriting the equations. Oops, I've hidden the what I just wrote behind my head. All right, so then it's just a matter of writing the all of that into a matrix equation. We could substitute VA equals 10 into the two equations, or at least into the KCL at B equation. That's the only one that uses it. Or we could just leave all three of them, and that solving for that should give us our VA, VB and VC. And then the output voltage is V out, and you could do this a number of ways. I just prefer to say that V out equals VC minus VB, right? So that's all I wrote in the answer. I didn't even calculate it, and it's still giving me the check mark. Okay, so that is question 1 on homework 4, and I'll try and get through the others before Saturday. I should have time tomorrow on Wednesday.